Hello. Up to now, we've been talking mostly about linked list, but I did that to get everybody up to speed on it. What I want to start now is what is a data structure and the more formal way of looking at it. This is in the text, it's chapter 3, but I've made some changes in it here and there, maybe to simplify it. What we're looking at is an abstract data type. That's always abbreviated, as all good computer scientists do, to ADT. You know, we always have the acronyms. And what it is the data and the things we're going to do with it. And there's two layers, there's two levels to look at. I'll say two views of it. The first view is the user view, and the second view is the implementation view. The book has a third view, which it calls the logical view, but all that looks like to me is where we use it. So I'm not going to really worry about that. These two are separate. The user does not need to know the details behind the scenes. The user should be able to use it without worrying about the little things. And the user should be able to keep doing what they do, even if we change the implementation. In fact, for what I'm going to do today, I'm going to talk about 3 possible implementations. First example, actually I think it's the second in the book. I'm not going to do unsorted list. Our example is going to be a sorted list. You've already been doing it. When we did the binary sort, that was a sorted list. When you did homework 3, that was a sorted list, I believe, or I don't think we used it as a sorted list, but it was there. So we've been looking at this. Now, what are the pieces of it? Well, let's look first at the user level, the user view. The user has to be able to create a list, and usually we want them to be able to create a blank list. We do that regularly every time we declare an array. When we declare an array, there's nothing in it. Now, we need a function that will tell us if the list is empty. We don't want to go to the list and try to take something out, delete something when there's nothing in there. So we'd like to make sure that we can ask, is it empty? There's also a suggestion we might not want a function called isFull. Now, this function would be needed if you were implementing the sorted list as an array, because you have to decide on the size of the array. You won't need it if you're doing a linked list. Both of these should be Boolean functions. They return true or false. And there's no problem with that. You've done many of them. Now comes the operational things we want to be able to do. We want to add an element. That's probably a void list, a void function. We want to delete an element. You've seen two possible deletes. We might want to do it by position, or we might want to do it by value. So most of the time, we probably want to do it by value. And the third one is to find an element in the list. So no matter how we implement this function, this abstract data type, those are the things that the user wants to be able to do. And that's all the user wants to be able to do. The user doesn't want to know there's a linked list behind it, or a vector, or whatever. The user just wants to be able to implement these functions. Now, the implementation view. Well, here we have a choice. Even what we've been doing so far, we've sort of had a choice. We've talked about two different kinds of implementations. Most people think of a sorted list as an array. Well, that's one implementation. It's a reasonable one. There's also an implementation using a vector. If you remember back to 104 or whatever, a vector is like an array. You can access the elements in it the same way, but the difference is a vector does not have to have a size. It can grow. It can shrink. So in that respect, if we have a vector, we don't have to worry about the isEmpty function, usually anyway. And then there's the different approach using a linked list. Any one of these is a reasonable implementation. No matter which one is being used, the functions from the user's viewpoint shouldn't change. It's all the behind-the-scenes work that's going on. Why 3, or why might we want to use a different one? Well, the delete function is actually easier in a linked list than it is in the other two. The add function is also easier. But if you're just putting things in and sorting them, the array and the vector are probably easier. So it depends on what you have to do, what you do most. That determines which implementation you think is the most efficient. I'm going to write a little program with some of this, and in that program, I'm going to also have a new item. I'm going to show the built-in sort routine, which is in $include algorithm. The reason I want to do this is because the sort is an efficient sort, and the one that we use, that you're using in homework 3, is not the best. But I don't want to spend time talking about algorithms, since we have a second course that's supposed to do that. So I want to just say, let's let the machine do the sorting if we can. So what I'm going to do, we'll show that in a few minutes. Now I'm going to bring up the array. I'm going to bring up my Visual Studio. And I'm going to start a program. And I'm going to say, let's see, we'll call it, I'll call it slist using array. So that's what we'll do. Let's see if it wants to come up. I'm going to need, besides IO stream, I'm going to need string. I'm going to read items from a file, so I'm going to need fstream. And I'm going to use the sort routine, so I need the algorithm. And I'll have using namespace stem. Then I want to be able to vary the amount I read in, so I'm going to say const int n equal 10,000. The file that is h1 data that you were using, I think it has like 22,000 items on it, so we can easily get 10,000 off it. Then I'm going to define a class. This is the usual way you define an abstract data structure. So I'm going to describe the class as slist. And everything in it I'm going to make public because I don't have any reason to hide anything at this point. The heart of it is an array, and it'll have n elements in it. And it's an array of string. I'm going to have another item, which will be useful for the two Boolean functions I talked about, is empty and is full. And that's basically going to be an integer, and it's going to be index, and I'm going to start it off as 0. When you do something like that, when you put a value in, what you're saying is, every time we create an object of type slist, it will automatically set the index to 0. That way we don't have to. That's very useful when you're creating linked list types with nodes. If you want to set them to null, you can do it in the creation part. Now we need some functions. But first, let's go down and write a little mainline program. I'm going to have an slist, and I'll call it vals. And I'm also going to have an if stream, which I'll call inval. And I'm going to open inval, and I'm passing it what you've seen about 10,000 times. You might think so. Uses FP Ford Fall 2020 CSC 225 H1 data dot text. And I'll have the semicolon just off the edge where you can't quite see it, but that's okay. Then after that, I'm going to read in the file, and I'm going to create a function to do that. So I'm going up here and I'm going to create a function. It will be a void function. It will read in bulk. I want to read a lot of things, and I'm going to pass it an if stream, and I want it to be able to change it, so I will need the ampersand, and I'll call it inval. It's the same name I used in the other one, but I don't think we'll get into trouble. And all I'm going to do is read in the elements. So I'm going to say for int I equals 0, I less than 10,000, well, pardon me, I less than n, I plus plus, I will take in the element into ST INX, and then I'll add 1 to INX. And since it's on the right, it does it after I put in the number there. Now, this might not be the best way to do it. In this case, for example, INX is, well, no, it's okay. It's the number 1 past how many we have. Now, here's the nice thing. We'll do the sorting in one line. We'll say sort ST plus INX. What we're saying is that the sort should go to the ST. ST is the name of an array, but it also is the first place in the array. It's technically a pointer to the first place in the array. ST plus INX is a pointer to the INXed element of the array. But remember, I said INX was the next one, the one we hadn't put in. So this basically is taking us to the end of the array. We're going from 0 to INX plus 1, and we're sorting the whole array. Now that is a nice little function. That's about the fastest way I've ever sorted anything in my life. So I kind of like it. Now we've got to sort it. Well, the usual thing is we want to make sure it's there. So I'm going to take my vowels. First of all, I'm going to take vowels, read in bulk, in val. Then I'm going to print it out. So I'm going to have a P list, and I actually don't think I need anything as an argument for it. And this again will be a void P list. I will go for int I equals 0, I less than, I'll use index because we don't know, it might have changed at some point. And I'll use I plus plus. I will see out. I think I'd like to have the place. And a couple of things. N ST I. And I think that'll be enough. I could put beginning of list, end of list, whatever you want it, but I'm just going to leave it that way for now. Now at this point, what we should do is check it out. Is it working? Is this part working so far? So let's see. I'll get rid of all this stuff at the bottom here, and we'll just try our luck and see if we can get it to work. So compile it, no errors, run it. You know what I forgot, don't you? I forgot it in the line. So I think I better put that in the line in if we want to have any chance to read anything. So I'll do it that way. And here we go. As you notice, they're in order. And they're not in order in H1 data, I'll guarantee you that. And if all goes right, I'll have 9,999 will be the last one there, and it is. So I've just done putting in a lot of elements in bulk, and I've just taken care of printing things out. Now, if I want to have an is empty, all I would have to do is have a bool is empty, and I don't need anything there. And I can return, I need a boolean, so I can return INX equal 0. If it's 0, I'm going to return, it will return true. I like to put a parenthesis around that. And I think I've got it just the right way. It's a very easy function. I'm not going to write an is full because I'm using an array. I don't think I really need one. Well, I guess I could. I'll do bool is full, and the argument will be I don't want to go above the end of the array, so I'll say return INX equal n minus 1. That would mean that we don't have any more room to put anything in. Oh, pardon me, bn. It would be past the n. So there are those two functions. Now the hard functions. How are we going to find things? How are we going to work around adding things? Those are the next problems. So the next function I would want is void add to list, and I want what I'm going to add, so it'll be a string, and I'll just put new val, and we have to figure out how to do that. We want to put new val in wherever it belongs. We probably could use a binary search. That would probably be the fastest way to do it. We also could just go down the list one by one. I think I kind of want to go down the list one by one because I just don't feel like working out a binary sort. In fact, I think I'm going to leave that to you to figure out how to do that. And you just have to look how we have it. This is really as far as I want to get to begin talking about the implementation. So there is the first part of an implementation using an array. So I will save this, and I'm going to go close the solution, and I've got to save those. And now I'm opening another one. And this one's going to be called vector for slist. And I'm just going to copy in what I had. And I have to add one more item up here. I have to add vector. # include vector. And now this is not a string. It is a vector of string. And there's no size required. In fact, I got to give it a name, st. And now when I'm reading one in, I use the push. So I say st dot push, st dot push. Now what I love is it gives me it right here, so I don't have to think about it. Pushback. And what about the sort? How do you do a sort of this? Well, that's interesting. There's a special word for it. You have the sort dot begin and you go to sort dot end. Now I think I got everything right there, yes. The p-list does not have to change because I can print it out the same. I can look at it the same way. I don't have to change anything here. That's what I wanted. I don't have to change a thing. And so let's see if there's any hope that I got it right. I did make some error. Oh, I spelled vector wrong somewhere. It seems to say that's what I did wrong. Pushback, no such item for ST. Oh, I know that's wrong, pardon me. I have to have another variable. I have to have a string in S. I have to read in S, and then I have to push back in S because there's no read that comes with the vector. I can't read it right into the vector. I have to do it this way. So let's see if that was what it was complaining about. Looks like it. Didn't print anything. And that worries me. I think it was reading them in properly. Let's see. Did I do anything wrong there that you can see? Well, I'm going to show you a nice little trick. I'm going to go right here and put in a breakpoint. And now I'm going to say debug, and I'm going to start debugging. As I do this, when I get to that line, I can look at what I have. I've read in Baba, that's in INS, and this is the actual class, the object I'm looking at. So this, there's nothing in it yet, and INX is 0. Then I'm going to do F11 to go to the next line, and it's still putting nothing into this, so there's something wrong there. That's what's causing the problem. That's debugging. Very nice little trick. I may want to talk about that again at some point. Right now, I don't see why it's insisting on not doing it. Maybe pushback. No, it's got to have INS there. I may have to stop it here and just let it go for now. It should be a minor problem, but it seems to not want to do it, and that bothers me. I've got ST there. It's a vector. It did accept pushback as one of the methods for the vector, so it should have taken it. I'm going to debug it once more just to see if I missed something. There is nothing in ST at this point. Oh yes, there is. Baba's in ST. And now if you watch, you'll see ST grow. I think. ST now has size 2. And if I look at ST itself, ST has Baba and bacteria in it. So now if I I'm going to stop it because otherwise I'll stop all the time at that one line. I don't want to. So I'm going to remove this and I'm going to run the program. It's getting in there, but I made a mistake here. This is where I made the mistake, I'm certain. And I'm going to have to look up the exact wording for that. I thought it was that, but it looks like the machine doesn't want to do it that way. Let me see if there's some chance that now there is a begin. And I'm going to try it without the quotes and see what happens. This is what I thought would happen. It's basically telling me that I can't do that line. That's the error message. There's no such thing. You just barely see it. So I was right the first time. Those are definitely there. And now let me run it. I will have to look up what I did wrong. I'm sorry, but I just can't remember what it was that I did wrong there. Definitely something, but we'll get there. We'll figure it out. So you might want to look too. Now, how would I figure that out? Well, I happen to have out here already under my setup, I have, there's the sorting of the array, as I said it would be. Now I have to, the easiest way to do this is to put in that I want to sort for, I'll use the Wikipedia here. That's a funny way of doing it. We don't really need that. But you should see it should just say vec.begin to vec.in. So I shouldn't be having a problem with that. And their output is no different from mine. So I'm wondering what it is that I did wrong. Let me bring it up again. ST is that. I did push it into there. It is getting into there. I don't see where there's any problem here. One problem could be I didn't change INX. That's the whole problem. After I read it in, I should say INX equals 1000. I thought I had done it when I did the I++, but I didn't. And that's what's, oh, it's 10,000, pardon me. It's actually N. And now we'll try running it once more. And now it's working. So there are two implementations. And if you noticed, I didn't have to change anything in the main line to do those two implementations. Now, I think that's enough for now. Probably I'll put out another one soon, another video, showing the part with the linked list. We've already more or less done that. And then we'll talk about adding and deleting. So I'll see you later. Bye-bye now.